Hello everyone, this video is on redox reaction or oxidation reduction reactions. I know this is really new for everyone, we just learned about this, and I think this is probably what most people are struggling with right now. I know I was a bit confused by it in the beginning, but I think once you kind of understand the vocabulary and you kind of get what is trying to be represented, it might help or it might not. I don't know. But I will try my very best to make it more clear for everyone. So let's start with defining what it is. So an oxidation reduction reaction, or redox for short, because I know I don't want to write that a billion times. An oxidation reduction reaction is when a reaction has changes in electron distribution that produce changes of charges in the, should be from the reactants to products. So basically what that all means is that when substances undergo a chemical reaction, there's changing, there's reordering, combining of the elements. And sometimes what can happen is elements can lose or gain electrons when they undergo this. And so redox reactions just show those when that happens. And so just remember, oxidation reaction isn't going to be classified by itself. You're not just going to have a reaction that's solely oxidation reaction. It just goes with. It's supplementary to the other types of reactions. And so it's kind of hard to picture it or kind of like wrap your head around all those words. So let me draw an example. So the numbers I'm putting on top are the oxidation numbers, which I will explain in 1 second. So the equation I've just written out is, this would be your net ionic. So we started from whatever we started with, we did the total ionic. This is what we're left, and this is what we turned into the owls. So what these oxidation numbers show is it shows the charge, it kind electron number kind of these elements. So if you have something by itself, it's just 0, and this has a -1 charge, -1, -1, -1, 0. So what you can kind of see is that from our reactants to our products, chlorine gained an electron. And we know it gained an electron because the charge decreased, and electrons are negative, so they will make your charge go down. But from the reactants to the products, bromine lost an electron because its charge increased. And so that's basically what oxidation reduction shows. It shows how the electrons moved around. So there is a lot of vocab that goes with this. So let's start breaking it out. So oxidation, which is an O, is a loss of electrons by an atom ion. And when this happens, the charge increases. So in our example above, bromine would have been the one to undergo oxidation. Technically, you'd write it as that because that's what it is in the reactants. because bromine increased. And it's called oxidation because originally, back when they named it, they thought only oxygen caused this to happen. Obviously, that is not the case, but the name stuck. So that is why it's called oxidation. It has nothing to do with oxygen. So the opposite of oxidation is reduction. And that is when electrons are gained, and that's when your charge, as the name suggests, decreases, reduces. So in our original example, that's what would have been chlorine. And then, so there are a few acronyms to remember this. I'm liking oil rig. And what that just is oxidation is, oh, I don't remember what the L stands for. Oxidation is loss, and then reduction is gain of electrons. That helps. I know when I like to do these, I like to think about it as oxidation is increase in your charge, and reduction is reducing your charge. So, and then there's also Leo Gur, which is basically just saying same thing in the opposite order. Loss electrons oxidation, gain electrons reduction. Whichever one is going to help you remember it. That's your choice. So we now know about oxidation reduction. We also have to talk about reducing and oxidizing agents. So let's go with oxidizing agents. Oxidizing agents are the substance being reduced, aka the one that underwent reduction. So when you have agent, it's the opposite of the name before agent, and it's just going to be whatever that reduction was, and then your reducing agent, again, is the opposite, is the substance being oxidized, because it's causing the reduction, so that's the one undergoing oxidation. And a note I should make is oxidation and reduction are always occurring together. You're not going to see one and not the other, because you have to have the same amount of electrons and gained and lost for it to be balanced. So oxidation and reduction always occur together. So that is the breakdown. So I hope that part makes sense. When you know if you're doing oxidation, when you know if you're reduction. The thing that is very complicated is assigning the numbers. So every element, not every every element in your chemical equation is going to have an oxidation number. And basically what this oxidation number is, it's the number of electrons gained or lost. By the atoms forming the compounds. So there is a lot of rules So, let's start. So, if you have a free, uncombined element, it's, O2, Cl, zinc. These all have zeros because in their natural state, probably, in their natural state, they haven't lost or gained electrons. They have the amount they started with. They're neutral, 0. If you have a monatomic ion, that's going to have the charge of, each one's going to have the charge of that ion. So, say you had NaCl, that's going to have plus because that's sodium's charge. This one's going to be minus because that's chlorine's charge. So those are pretty simple. It's just, whenever you're assigning charges, that's it. Say you have a covalent compound. In a covalent compound, the less electronegative, the less reactive one, because covalent, remember, is 2 nonmetals. If you have that, the less reactive one is going to get the positive charge, and then the more reactive is going to get the negative charge, because you have to have a positive and a negative. Let's see if I have an example somewhere. Say for instance, nitrogen, dinitrogen trioxide. Oxygen is always noted. Oxygen, except for very rare cases, oxygen is always 2 minus. And so, since oxygen's 2 minus, and there's 3 of them, there's 3 oxygens, that means this has a total of -6. And so we need this nitrogen to cancel out and have +6. And since we already have 2, we know we have to do 3. And so that's kind of covalent. So, okay, so the sum of all the oxidation numbers of all the elements in a compound will equal 0. So you had like KCl +1 -1, that equals an oxidation number 0. So that's going to happen if you're in a polyatomic ion, say SO4, that is going to equal the ion charge, the sum of all the oxidation numbers. This isn't going to equal 0, this is going to equal -2 because that's sulfate's charge. So as we already stated, oxygen, so that's -8, and we need to get to -2, so that's going to be +6. Okay, hydrogen is going to be +1. In a compound, it's going to be +1. If it's a hydride with something that's less electronegative, you may see it as -1. For instance, potassium hydrogen, that would be +1 -1, but again, I think that's a rare case. The exception for oxygen, if it's a peroxide, then it would be -1. Say like H2O2. It's just how the math comes out. You just need to make sure you're getting that. So generalization. Group 1, alkali metals are going to be +1. Group 2, alkali earth metals are going to be +2. Group 3 is going to be +3. Group 15, 16 are going to vary, but And then group 17 halogens are in binary compounds with metal are going to be -1. So for most of the time, it's going to be just the charge of what it normally, the element's normal charge. You just have to be careful with things like nitrogen, sulfur. That's an example that comes up a lot. Those are going to be iffy because they can vary. So, with everything in life, the best way to get better at this is to practice. And thankfully, I have a lot of practice. So, let's start with sodium to sulfate. Okay, so sodium is in the alkali metals. So it is going to be +1, which gives this +2. We know oxygen is going to be -2. So we now know we have -8. Now, these need to, oh, that's not a 4, that's a 3. Okay. I can't read tonight, apparently. Okay, 3, so we have -6. So, we need sulfur to be something positive to balance these out. And, or no, we need sulfur to be something to balance these out. So, this has to be +4, because 2 + 4 equals 6. So a lot of these, kind of, if you think about it like a math equation, maybe that could help, and you have a variable you need to solve for. If we do another example, potassium, manganese, and oxygen. So remember, potassium's always going to be +1. It's in that alkali metals. Oxygen is going to be -2 always. So we have 1 and we have -8. So we need something positive that's going to combine with 1 to give us 8. And so that's going to be manganese +7. So these can be very variable except for those ones that are set in stone. So say we had calcium nitride. So we know calcium is +2. It's in that alkali earth metals. We know we know oxygen is -2. So that gives us -6. We need nitrogen to be something positive that when multiplied by this and added, it gets us to -6. So this is going to be +5 because I believe, because when you include that 2, this actually makes this -12 because we have double the amount of this. So that's why, because we only have 2 here, we need this to be 5. 5 times 2 is 10 to get that 12. So just remember, if you have subscript, you need to include that. It's like NO2, -2, so that's -4, +4. N2, remember, anything by itself, no matter what, it's just 0. And the rest of my examples are pretty similar. Say we had NH4. So remember, we're going for a total of +1 because it's an ion. It's together. We're not going for 0. And so remember, hydrogen is always going to be +1. So we have 4. So we need this to be -3 to get that +1 we're looking for. Okay, so that's how to assign oxidation numbers. So now we have to figure out, like, when is it oxidation, when is it reduction? And I know we've gone over the definitions, but let's see an example. I'm not going to do the whole equation because that would take forever, but I will do the net ionic. So say we had magnesium, just solid, plus copper 2, which came from something. It was aqueous. It gave us magnesium, which was aqueous 2+, and it gave us copper solid. Okay, when this happens, let's first, nope, I didn't. Okay, let's give it oxidation numbers. So anything by itself is 0. Those are going to be the easiest ones. Copper, because it's 2 plus ion, it's going to be 2 plus. And then this magnesium, again, is going to be plus 2. So, what may help is connecting them and drawing little boxes. Okay, so we see that this magnesium is going from 0 to plus 2. So that is an increase in the charge. We've gained electrons. We've increased the charge. So that's oxidation based on our definition. And then these coppers, we've gone from -2 to 0, which is it's a decrease. Because we haven't gone from -2, we've gone from +2 to 0. That's a decrease, so that's going to be reduction. We've reduced. And so if it asks you to label them, you'd say the one that underwent oxidation would be magnesium, and you write it however you see it in the reactants. And then if it asks what did reduction, you would say Cu2+. If there's coefficients, you don't need those. You don't need suits matter, but you do need that ion. And then if it asked for, say, the reducing agent, you just know that's the one that underwent oxidation. It's the opposite of its name. It's going to be magnesium. And then the oxidizing agent would be copper, because that's the one that underwent it. So I think this video has been plenty long now. If you need more help with this, please ask me. Feel free. I can do a video on practice problems, working some problems, if that would be helpful. I believe this was maybe in the owls. I don't think there was a lot of it. There's definitely some in that giant packet. If you have Miss Mock, there's lots of practice with this. And you can do this just on any equation you work at the end. You can just practice with this and do it. I will note that redox tends to only happen on synthesis reactions, decomposition reactions, single displacement reactions, and combustion reactions. You don't see this in double displacement or acid-base neutralization, because that is double displacement, because, you know, they kind of they balance each other out when they switch. So these are probably the only four you're gonna see it on. So that should give you, but yeah, that would definitely be a way to practice. Just, you know, you're already working an equation, you've got the net ionic, just do the oxidation numbers and see if you came up with redox. I hoped this helped and made some semblance of sense. Please don't hesitate to reach out to me if you have any more questions, need me to explain it again. I will definitely make more videos if that needs to be done. I'm pretty much up for anything. Yeah, I really, really hope these help. Thank you so much.